Warning: the video you're about to watch contains mathematics at the level of precalculus. All material has an assumed prerequisite of college algebra and trigonometry. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, Professor of Mathematics at Cosumnes River College in Sacramento, California. In this video, we'll start into logarithmic functions. So this is within a chapter or a topic, a major topic called exponentials and logarithmic functions. And you should have already watched my video series on exponential functions and the natural exponential base. Those will all be required topics to be able to understand this. However, it is also assumed that you have seen all of this material. So in fact, in this video, it's just a review of properties of logarithms, which you have seen for multiple semesters at this point. So there's no need for me to go into too much detail, but just as a reminder. So the logarithmic function with base b is defined by this bijection. So that's what that double arrow is called. It's a bijection. The log base b of x equaling y is the same thing as saying b to the y is equal to x. The way you would read that is you would say log base b of x is equal to y if and only if b to the y is equal to x. Now, when I'm teaching this to, let's say, an Algebra 1 or Algebra 2 class, I just say, well, if you have the log base b of x is equal to y, another way to rewrite that is what I call the circular argument, where I say b raised to, that's what that caret means, b raised to that y will equal the argument of the logarithm. So that b, I'm going to read it out loud, b raised to the y is therefore equal to that interior argument x. It's a way to transform between logarithms and exponential, or actually maybe I should say it this way. It's a way to transform between a logarithmic form and an exponential form. It turns out that logarithms are just exponents. However, a lot of that statement is often lost on students. A lot of people in general don't quite get that a logarithm is actually an exponent, but it is. I mean, you could see it in this picture, that the exponent of this b is y, and that y is equal to the logarithm. So the logarithm actually is an exponent. But again, a lot of people don't quite latch onto that completely willingly. So a couple things that are critical to note about this. The base of your logarithm must be positive. Also, it must not be 1. There are really good reasons why that's true. So if you focus on the logarithm itself, you'll never understand why that's true. But if you focus more on the exponential form, it might start making sense. For example, if b were equal to 1, you'd have 1 to the y is equal to x. Well, 1 to any power is just 1. And at that point, x would just be 1. So it'd be a constant, not an exponential function. So that's why the base cannot be 1. The reason why the base must be positive is by definition of an exponential function. The function b, oops, that's not supposed to be a highlighter. The function b to the y is an exponential function as long as its base is positive. The reason why is if you have negative bases, let's say like a negative, let's say you let the base be a -1. Since y can be any number, it could be a half. And then you'd be talking about the square root of a -1, and that's a problem. So that is why we require the base to not only be positive, but again, to not be 1. And since that base b is the same b in the logarithm's base, well, then that restriction carries over. Another thing that's critical, probably more critical than the conversation about the base, is the fact that x must be positive. X is the argument, let me use green, x is the argument of the logarithm. It's the input for the logarithm there. And it's also the output for the exponential function? Well, exponential functions are never zero, nor are they negative. So therefore that output has to be positive, and thus the input of the logarithm must also be positive. Those are critical things to remember because the fact that the argument for a logarithm must be positive comes up all the time in calculus. Now let's move on to looking at the laws that you're required to know. And here they all are in their glory. And at the top, I just state, you must know all of the following properties to succeed in calculus. There's none of them that you can just say, oh, I'll forget that one. All of them are critically important. And luckily, you've been introduced to all of them and worked with all of them to get into precalculus. So if you're watching this video series, you're in a precalculus course, you've seen all these. There's no need for me to review them, but they're here. If you want to pause the video and write them down, you're more than welcome to. Probably, I would say the most critical ones, well, you know what? They're all super important. The only one that I tend to never use, or maybe I should say rarely use, is this guy right here, which is called the change of base formula. It's nice to know, but I just rarely use it because generally speaking, I always work in either log base 10 or I work in base E, which is a natural log. So that's kind of neither here nor there, but I'm just letting you know. All of these are important in their own ways. Now, like I said, this video is just a short recap. I really didn't do anything. I'm not proving these. I would prove these if you were in Algebra 2, maybe. And that's about it, because they've already been proved by the time you get to college algebra, and definitely you've worked with them by the time you get to pre-cal. So, yeah. So write down the ones you need, and I'll see you in the next video.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.